Hey everybody, this is your pre-calculus 7.3 video about the notes and the worksheet. So in this lesson we're talking about trig equations. So it's an equation, which means you have to have an equal sign. And again, trig is when you have sine, cosine, tangent, cosecant, which is the inverse of sine, secant, which is the inverse of cosine, and tangent, which is, or cotangent, which is the inverse of tangent. So these are going to be problems where you have to use your algebra concepts related to trig functions. For example, you're going to have to use substitution and solving equations. Applications include problems about blood pressure, the Ferris wheel, a holding pattern, projectile motion, heat transfer, and carrying a ladder around a corner. So those are the possible word problems that we might do. Your objectives are to be able to solve equations involving a single trig function, like just one, to solve equations using the calculator, and then to be able to solve trig equations quadratic in form. So about that, you might see this equation, which is called the Pythagorean identity. I just put PYTH, which is sine squared x plus cosine squared x equal 1. Now remember, if you were to type the left side in the calculator, like on Math Excel, you have to do up arrow 2 like that, but that's not the way it works on the Inspire calculator. You would need to do sine x squared plus cosine x squared, and it probably even does parentheses around the x. And then function 2 would be 1. I'm not going to really show that right now. Just know that on Math Excel and when we write it, the 2 is there, but when you're graphing it, you got to do parentheses squared, not the little 2 right there. I'll show that more when we actually do problems, if that applies, but I know that the 2, as we write it, goes here, but if you graph it, it goes out there. Okay, other things is going to be using fundamental identities and solving using a graphing utility. So one of the things I wanted to mention is you're still going to need your unit circle packet, but in particular, flip the page over, and here's your reciprocal properties, which is where it's 1 over. Here's your quotient, which involves division. That's not just a 1 divide by. But then this is what we're talking about, quadratic. Okay. Now, this is sine squared x plus cosine squared x equal 1. Now, if you were to solve for sine squared x, it'd be 1 minus cosine squared x. If you were to solve for cosine squared x, it's 1 minus sine squared x. Okay, so really this one identity really becomes 3. And in the same way, if you have 1 plus tangent squared is equal to secant squared, then you could say tangent squared is secant squared minus 1. You can even say 1 is the same thing as secant squared x minus tan squared x. So if you were to see those with tangent and secant, they come from that Pythagorean identity. And lastly, when you have 1 plus cotangent squared x equal cosecant squared, that also means cotangent squared x equal cosecant squared x minus 1. Or you can even set it equal to 1. 1 is the same thing as what cosecant squared x minus cotangent squared x is. Now later on when we do some proofs related to trig, you might be at this step and then all of a sudden your answer is 1. Or you might be at this step and then all of a sudden your answer is 1. So don't be surprised if that happens. And then we already talked about the odd and even before, so I won't go over that again. But those are the Pythagorean identities. So it's 3 identities, which really turns into 9. Okay. So now checking whether a given number is a solution means substitute a value for the angle, theta, and see whether it's true. You also will need to find all solutions. Now, before we just said within a certain interval, like I'm going to say before we said something like, what about negative pi to pi? Or negative 2 pi to 2 pi? Now here we have to be general. And so you're going to have to list 8 solutions, for example. The general formula may be start with pi thirds, which is like 60 degrees, and then every revolution around it, 2 pi k or 2k pi. Those mean the same thing. And I put that here. And then you substitute different numbers for k. So you could say 2 pi times 1, 2 pi times 2. It just means like you're at 60 degrees. Do you want to loop around 0 times? Then you're there. Because 2 pi times 0 is 0. You're there. So that's it. Or for this one, we're going to go all the way around once and then stop. And on this one, we're going to go all the way around twice and then stop. So 2 pi times 2 is 4 pi. It's going around twice. So that's how that looks. So the general formula is going to have a k variable. Now when we talk about solving a linear trig equation, that doesn't mean it's a straight line or not curvy. It means the exponent is 1, like sine x. So just as a reminder, if you're graphing and say you press the trig button and do sine x, say you're in radian mode, it's wavy, which is what we want. But if you were in degree mode, it does look linear, and that's not what we're talking about. This is wrong. It's not supposed to be in degree mode when you're graphing. It needs to be wavy. Okay? So we might have something like sine x equal, I don't know, let's just say a half. And so x is the inverse sine of a half. Remember, we can go to the y answers. Since remember, x relates to cosine, y relates to sine. We want where sine is 1/2. And so that'd be at pi 6 or at 5 pi 6. Now, just as a preview for what we're doing, that means the general formula would be pi 6 plus 2 pi k and 5 pi 6 plus 2 pi k. Because it loops around as many times as you want and stops at pi 6. or stops at 5 pi 6. It may also say some terms like least and or smaller, least or smaller, which would be the pi 6, and then the bigger one or larger would be 5 pi 6. Okay. Now there are some problems having to do with solving a trig equation. So what you want to do is pay attention to values of variables that affect the period, like the W, or shifting it left or right. You're going to need to write a general formula that gives all the solutions, then use the interval given to select which ones you need. Then for number 5, solve with radian mode. Express it in radians, rounded to 2 decimal places. And remember the valid intervals. So this should have been like sine -1 and tan -1 and cosine -1. So remember, we did this before. It was this when it was sine -1 and tan -1. And it was this when it was cosine -1. Now, in general, remember we said sine and cosine were all real numbers for the domain, and bracket -1 to 1 for the range. And remember those properties are right here. Both have a domain, -infinity to infinity, and a range -1 to 1. I'm not going to review everything right now, but you have your notes, and we've done the sections. Like this says, both of these have a range of -infinity to infinity, which is the vertical part. But because tan and cotan and secant and cosecant have asymptotes, those are the little dashed lines that are vertical. And so that's why the domain is not all real numbers. It would be everything except for these for tan, everything except these for cotan, everything except for these for secant, and everything except for these for cosecant. Okay. Now also, you're going to have some problems where it's quadratic in form, where it's like sine squared x plus sine x plus 1. Quadratic just means there's going to be a 2 exponent. Well, you could use u substitution if you want. Like you can say u equals sine x, and so that's the same thing as saying u squared plus u plus 1. So you might want to get used to that. Some people just think, well, I already understand it. So you don't have to use u substitution if you don't want to, but you could. Now, when you're doing problems like this, you could factor, and so it's going to look like FOIL. If it's not factorable, then you have to use the quadratic equation, which is this formula, the negative b plus or minus the square root of b squared minus 4ac, all of that over 2a, and then solve your trig equations. You also have to do some solving using identities, like the Pythagorean identity, like one of the 9 that I mentioned, or other identities like tan x could be replaced with sine x over cosine x. And you need to have it in the terms of the same trig function and then solve it. So, for example, you could think sine squared plus cosine squared is 1, could also be thought of as y squared plus x squared equal r squared. Because remember, sine relates to y and cosine relates to x. So when we have a problem like this, sine squared plus 4 sine x plus 4, that could be thought of as u squared plus 4u plus 4, and we would just make that as u plus 2 times u plus 2, or you could say u plus 2 squared. Now we rewrite that as sine x plus 2 squared. And for here we have cosine squared x. Well, back in the notes, we said cosine squared x could be written as 1 minus sine squared. And so that's what we put in our denominator. And so then we're done. So you are going to have some questions related to that. And then there's also going to be some where you're using your graphing utility like your calculator and do the intersections and round to 2 places. Okay, so now let's start with the problems. Now it looks like on accident, I accidentally did number 1 for you where it says sine theta is a half. Well, let's do it again. If you use the technique from a previous lesson, you're solving for theta, so you do inverse sine of both sides. And so that means look on the unit circle where y equal a half. And so that was the one that was pi 6 plus 2 pi k and 5 pi 6 plus 2 pi k. So again, we wanted the y value because it's sine. If it said cosine value, it'd be square root of 3 over 2. Okay, now on this one, it says solve on a normal interval 0 to 2 pi. So when you have a problem like this, you're going to add 3 to both sides, 12 sine squared theta equal 3, because we're doing plus 3 to both. And then sine squared theta equal 3/12, which is really 1/4. And so then sine theta would be plus and minus a half. Because when we do the square root of 1/4, that'd be a half, but you have to do plus and minus. Okay. Now, what that means is every place on the unit circle where the y answer was a half. Every place on the unit circle where y equal a half or negative a half. And so 2 of the answers are what we did earlier, which is pi 6 and 5 pi 6. But the other 2 answers are down here where this is negative a half, which is 7 pi 6, and where this is negative a half, which is 11 pi 6. And so make sure you use your commas between them. Don't use brackets. Just list them. So you have to use your unit circle. Okay, now on this one, we have cosine 3 theta equal negative 1. What we first do is try to get the 3 theta by itself. And so technically that's inverse cosine of negative 1 first, because we're doing cosine negative 1 to both sides. So this part just cancels, and so it's 3 theta equal cosine negative 1 of negative 1. Now what that means is look on the unit circle where x equal negative 1. It's x, not y, because we have to do with cosine. So where was x negative 1? Right there at pi. Now what that means is then we say 3 theta equal pi, and you're going to have to divide by 3. So theta is pi thirds. So that's that answer. So that'd be your starting point. Now, what you really may want to do is you may want to graph function 1 is cosine 3x and function 2 is negative 1, and set your x min to be 0 and x max to be 2 pi, and see where the intersections are. So sometimes you may just mathematically get one solution, but then they're saying, well, this has 3. How do you know if it's 3 or 2 or 4? The easiest way is basically graph it and find out. Now, what we could have done is we said theta, well, what if it's 0? Then it would be pi. But I'm not going to get into that. I think that's a little complicated. So let's just stick with this. We have cosine 3x, and we have negative 1, and that's all the bottoms, and set your window 0 to 2 pi. And so 1, 2, 3 times. 1, 2, 3 times. Now the trick is you're going to have to get the decimal equivalent, and it has to be in terms of pi. So, whoops. Menu, analyze, intersect, between here and here. That's the 1.047. Well, that's bigger than pi. I mean, that's bigger than 1. Sorry, that's bigger than 1. And so if you say pi, that's the, that's the 3.14 stuff. Well, if you do pi divide by 4, it would look like that. If you do pi divide by 3, it would look like that, which is what we want. So, like, if you're doing those problems by paper, you may want to say, oh, I need to find an exact answer that looks like 1.047. Well, that'd be pi thirds. Okay, so that's the first one. Now, when I'm back at this screen, I just go back to the current, and I do menu, analyze, intersection. Between here and here, I get 3.14159. So most of y'all would know that's just pi. Okay, 3.14. And then the next one, analyze, intersect. Now technically on this problem, if I wanted to, I could do minimum, but it's not worth it because I don't want to set you up for failure. -1 just so happens to be our minimum, but you can do intersect, and that's right there. Remember, just move your numbers. So we get 5.2359. Now, for one like that, that's not that obvious, you may want to say try 4 pi thirds, try 5 pi thirds, etc. If you have one that's a 3 down here, then the other one probably is also. So if we go to 4 pi thirds, it looks like 4.19. And 5 pi thirds would be 5.236. And that's what we want. So there's how you get all three answers. Okay. Now on this one, we want sine of 2 theta is negative a half. So we're first going to do inverse sine of both sides. And so that gives us 2 theta is inverse sine of negative a half. Well, that means where is y equal to negative a half? Right there at 7 pi 6, and right there at 11 pi 6. Now, don't just put those as your answers because we're not done. There was a 2 theta there. So you need to say 2 theta is 7 pi 6 and 2 theta is 11 pi 6. Now, when we divide by 2, you could think of that as 7 pi 6 times a half, which is 7 pi 12ths. And this could be like theta is 11 pi 6 times a half, which would be 11 pi 12ths. Now you notice when we did the math, I only got 2 of the answers. Well, we could use our calculator like we did on the last one to get the next part. But now that I've taken you through this, remember the normal period for sine is 2 pi. Well, what is the period of sine of 2 theta? What is the period of 2 sine theta? Well, the period is the normal period divided by w, and so that'd be 2 pi divided by 2, which is pi. Well, what is pi with a denominator of 12? Pi is the same thing as 12 pi 12ths, right? And so what if we said 7 pi 12ths plus 12 pi 12ths? That gives you 19 pi 12ths. Oh, that's our answer. See how these are related? You just do plus 12 to the numerator. And then 11 pi 12ths plus 12 pi 12ths is 23 pi 12ths. And that's how you get that. So that's how you do it without even graphing it like I did earlier and guessing and checking, because I know sometimes y'all want to do it that way, but that's not the easiest way. Because you might have to say, well, 15 pi 12, 16 pi 12, 17 pi 12. Oh, I'm running out of time. What do I do? So don't get anxious. Don't get anxious. Just do it the right way and things will work out. Okay, hope that helps. we'll stop right there for this video.